Anyone from DURGASOFT? I think screen share got enabled. That's fine. Let me share my screen. I hope my screen is also visible, right? So yesterday we have stopped it. What happened if we deploy our applications on the physical servers directly? Okay, so let me recap. Okay, re-explain that one so that it will be very clear for you before moving further. So let me take this one actually. Let me move this to some side. Okay, yeah. Now you can see that this is going to be our physical server. There are three disadvantages that we have seen. This is going to our physical server. Suppose this physical server has some amount of CPU and some amount of memory. That is this one. Okay, now let me write it here. This is the physical server. Okay, it has 10 GB CPU. Okay, it has 10 GB memory, 10 GB memory, and 10 CPUs. 10 CPUs. Okay, it has this capacity of this physical server. Okay, so now if I deploy an application to this physical server, suppose I have deployed an application to this physical server. Okay, so if this application uses only 1 GB of memory, suppose let me think this application is only using 1 GB of memory, 1 GB of memory and 1 CPU. Okay, now what about remaining 9 CPUs? And see, this physical server contains 10 GB of memory, 10 CPUs, and our application is using 1 GB of memory and 1 CPU only. But remaining 9 GB of memory and 9 CPU is the resource wastage. Okay, how much is the remaining? 9 GB of memory and 9 CPUs were the resource wastage that we have as part of this. The first disadvantage that we have seen as part of this deploy, if we deploy our applications on the physical server, is resource wastage, right? The first disadvantage is resource wastage. Okay, so that's the thing. Okay, okay, what is the resource here? Resource means CPU and memory. That's what the resources we call it as. Okay, so sorry. The second disadvantage that we have if we deploy our applications to the physical server is, suppose if I want to deploy multiple applications, if I want to deploy multiple applications, I need to purchase multiple physical servers. Okay, I need to purchase multiple physical servers. If I want to purchase multiple physical servers, I need to spend more actually. So here the second disadvantage if we deploy our applications on the physical server is huge cost, high cost. And if I purchase, okay, if I purchase multiple physical servers, okay, I need to have a big space, big room to install that physical server, and I need to have a separate team to maintain that physical server. Okay, that is also the third disadvantage that we have, that is high maintenance. Okay, high maintenance. Okay, the fourth disadvantage that we have as part of this physical server is if by any problem this physical server got crashed, by any problem this physical server got crashed, then there is no way a new physical server, you need to purchase again physical server and you need to deploy your application. So there is no high availability if you deploy our applications on this physical server. No high availability, no high availability. What is high availability? At whatever situation it comes, our application should be available for our customers. Okay, that's what the high availability. Even though the physical server is crashed, okay, our application should be available, okay, automatically. Okay, something need to be there in the background so that our application will be 24/7 available to our customers. Okay, so in the case of physical servers, if we deploy our application to directly to the physical server, there is no high availability. Okay. Okay, this is four. There are many disadvantages like this. Let's stick to this four as of now. Okay, let's stick to this four as of now. Now, because of these disadvantages, there is a concept called virtualization has been come into the market. Okay, because of these disadvantages, there is a concept called virtualization has been come into the market. Okay, what is virtualization? Let me draw it that one. Okay, now here also we have physical server. Here also in the virtualization concept also we have physical server. Let me write something called virtualization here. Virtualization. Okay, now what will happen in the case of virtualization is we are going to have our physical server. We are going to have our physical server. On this physical server, okay, okay, now this is our physical server. Okay, this is our physical server. This physical server, I am taking same example, 10 CPUs and 10 GB memory. Okay, 10 GB memory and 10 CPUs are there with this physical server. Okay, now what will happen in the case of virtualization? How this disadvantages got removed in the case of virtualization? Let's see. Okay, now what will happen in the virtualization? As a down layer on top of the physical server, we will be having operating system. Okay, we will be having operating system on this physical server. Okay, initially. Okay, now operating system. Okay, this operating system will be installed, whatever the operating system it might be, it will be installed most of the places, most of the times for deploying our applications, people will be using Linux. Okay, so operating system will be installed on this physical server. On top of this operating system, there is something called virtualization software will be installed on this physical server. On top of this operating system, a virtualization software will be installed. What that software does, let's discuss. But yeah, a software will be installed that is called virtualization software. Okay, let me put it here. Virtualization software actually. There are multiple virtualization softwares available in the market. Okay, so one of the example is Oracle VirtualBox, VMware. Okay, so there are multiple virtualization softwares that are available in the market. Okay, so you people also might have installed Oracle VirtualBox in your local machines. What that Oracle VirtualBox virtualization software did for you? It helped you. Okay, it will help you. What is the virtualization software does? It help you to create multiple machines in a in that one single physical server. Okay, in that one physical server, you can create multiple servers. Okay, you can create multiple servers actually. Okay, this that is that is like how we can do that, how we can create because of this virtualization software. Okay, now let me draw that part. Okay, this is going to be our virtualization software. Now on top of this virtualization software, okay, because we have installed this virtualization software on this physical server. Okay, let's think this physical server is your laptop. On top of your laptop, you will be having your operating system, whether Windows or Linux, whatever it is. On top of the Windows like operating system, you will be installing Oracle VirtualBox if you have installed already. But yeah, just for example, this is virtualization software. What this virtualization software is doing, this virtualization software will be helping us to create multiple machines inside this physical server, inside your laptop, something like this. Okay, let me draw this. Okay, so second. Okay, this is one, this is second machine. in the on this physical server. Okay, and this is third machine on this physical server. This is going to be a third machine on this physical server. These are three different machines that are created. Because of that, you can create not only three. Just have an example. As an example, I have taken three. You can create multiple machines like this until and unless your physical server supports that particular number of machines actually. Okay, so this virtualization software will help us. VIR actually, virtualization software will help us to create multiple servers in one physical server. To create multiple servers in one physical server. What is the use of this? What's the use of this? And these are called this individual servers which is there in the physical server that were created because of this virtualization software. Okay, these are called virtual servers. Okay, these are called virtual servers. Let me write it one. These are called VMs, virtual servers. In case of AWS, we call them as EC2 machines. Okay, all these are same terminology. VMs, we call them as virtual machines. Okay, VMs, and this is also a VM. Okay, virtual machine. Okay, and this is also a VM, virtual machine. VM represent, do not confuse, VM represents virtual machine. Okay, so here this virtualization software helped us to create individual servers, internal servers on this physical server. These are called virtual servers or virtual machines or VMs or EC2 machines, instances. Okay, EC2 instances, so whatever it called, it's same it comes under same component. Okay, now I think until now it is clear. Okay, now how these disadvantages will be gone in case of this one, in case of virtualization. Okay, how means, instead of, see, I want to deploy multiple applications now. I want to deploy multiple applications now. I no need of purchasing multiple physical servers. I will only purchase one physical server and deploy multiple applications on these physical servers in different virtual machines. Something like this, app 1, app 2, app 3. I no need of spending huge cost because here only one machine is helping me to deploy multiple applications. Okay, here only one machine is helping me to deploy multiple applications. App 1, okay, this is going to be app 2, and this is going to be app 3, app3. You can see that here one machine, one physical machine or one physical server is helping me to deploy multiple applications on it because of virtualization or the virtual machines that were created because of virtualization only. Okay, now previously if the virtualization is not there, I used to purchase multiple machines in order to deploy our multiple applications. Now only one physical machine I need to deploy multiple applications, so I need to purchase only one physical machine. So huge cost disadvantage. Okay, when we compare to multiple servers, so the cost will be greatly reduced in case of virtualization, because instead of purchasing multiple, you are purchasing only one or two. Okay, until you need your needs, your requirement satisfies. Okay, so the cost it's a cost effective manner that you are going to do here, virtualization. Okay, so the huge cost disadvantage that we have in case of physical server is gone with the virtualization, because you can deploy in one physical machine only, you can deploy multiple applications. Okay, so that's why you know, of purchasing multiple physical servers, you can only purchase minimum amount of physical servers, so that you know of paying multiple you know of paying for multiple physical servers actually. Okay, there's a huge cost is gone in case of virtual machines or the virtualization. Okay, something like this. Now here what will happen, see, if you only have one physical machine, if you only have one physical machine, you only need to maintain only that physical machine. You no need of maintaining multiple physical machines, because you no need of, because you are following virtualization. Okay, on one physical machine only you are deploying multiple applications because of virtualization softwares. Okay, so there will not be any high maintenance also because you are using virtualization. Because you are using virtualization. Okay, now if you create these virtual machines in the cloud, there is something called auto scaling group that will be spread across all these machines, something like this. These machines, 3 machines will be part of the auto scaling group. Okay, what this auto scaling group does, if any problem happens with the one of the virtual machines or any of the virtual machines inside this physical machine, or terminated, this virtual machine got terminated, somehow some problem occurred or crashed, this auto scaling group will automatically recreate the machine without we manually doing that. That's a part of auto scaling. Now from this, what we can do, see, in this physical server, if the physical server is crashed, there is no mechanism with the physical server, it will not recreate the physical server. You need to do all the things manually. But in the case of virtualization or the cloud or the auto scaling group, if any of the virtual machine where you deployed your applications got crashed, automatically new virtual machine or new virtual server will be provisioned, will be created. Okay, so your application will be automatically deployed to that particular virtual machine or the virtual server. So you no need of handling high availability, automatically it is going to handle. Okay, in case of virtualization and the cloud, you are going to get the high availability. That disadvantage that we have with the physical server is gone with the case of, in the case of virtualization and the cloud actually and the virtual servers. Okay, all the 3 disadvantages that we discussed, okay, 4 disadvantages we have discussed, 3 were gone in case of virtualization. Now one is there, resource wastage. Now suppose this physical server is having 10 GB of RAM and 10 CPUs, right? This physical server is having 10 GB of RAM and 10 CPUs. Out of this 10 GB of RAM and 10 CPUs, each virtual server will be allocated some amount from that. Okay, suppose this virtual machine or the virtual server is allocated with 3 GB of RAM, 3 GB of RAM and 3 CPUs, 3 CPUs. Okay, so this virtual machine is allocated with 3 GB of RAM and 3 CPUs, and this virtual machine is also allocated with 3 GB of RAM and 3 CPUs, something like this. Okay, so the next virtual machine also allocated with 3 GB of RAM and 3 CPUs. Okay, let me push left side, something like this, and this virtual machine is also allocated with 3 GB of RAM, 3 CPU, something like this. Now from out of this 10 GB of RAM and 10 CPUs that is there with this physical server, each virtual server or the virtual machine is allocated with 3 GB of RAM and 3 CPUs from this 10 GB, because they are on that physical server only. Okay, they should use the CPU and memory from that physical server only. Okay, because they are deployed in this physical server. Okay, so now if our application is using only 1 GB of RAM, okay, 1 GB of RAM, 1 CPU, each of our application is using 1 GB of RAM and 1 CPU in different virtual machines. But virtual machine contains 3 GB of RAM and 3 CPUs, right? 3 GB of RAM and 3 CPU. Okay, out of this 3 GB of RAM and 3 CPUs of this virtual machine, we have deployed our applications on 3 different virtual machines. Our application is using app 1, app 2, app 3 is using only 1 GB of RAM and 1 CPU. Okay, so what about remaining 2 GB of RAM and 2 CPUs that are there with the virtual machine? So here also this is something called resource wastage. That means we are wasting the resources, we are wasting the CPU and RAM for that virtual machine. There is no proper utilization of the resources in case of virtualization. All other disadvantages were satisfied in case of virtualization, but resource wastage is still there, in the case of virtualization. One is, see, I hope you pulled got. Okay, our application deployed to virtual machines is using only 1 GB of RAM and 1 CPU. But with that virtualization, there is 3 GB of RAM and 3 CPUs. Okay, out of this, only 1 and 1 CPU, 1 GB of RAM is used by our application. What about remaining 2 CPUs and 2 GB of RAM? We are keeping the virtual machine idle. Okay, and we are paying the cost, right? So now what you need to do, you need to also properly utilize this all the CPU and memory that is there with that virtual machine. Okay, you need to properly utilize that. Okay, so the resource wastage disadvantages is also there with the virtualization. Now, because of this reason, not only because of this reason, there are many reasons, but yeah, we stick to this. You need to get a simple understanding first. Okay, because of this reason, a Docker has come into the market. Okay, a Docker has come into the market. Okay, in case of Docker, what will happen? Let's discuss. Let's see actually. File, new. Okay, save it somewhere. Save somewhere here. Okay, so in case of Docker, also we will be having a physical server. This is going to be our physical server with respect to Docker, something like this. Okay, this is a physical server. Let me name it that because you should understand. Okay, physical server. This physical server is having how much amount of CPU and how much amount of RAM. Same example, I am going to take 10 CPUs and 10 GB of RAM. Okay, on this physical server, we will be having our operating system, right? So we will be having our operating system, operating something like this. Operating system. This is going to be our operating system, something like this. Okay. On top of this operating system, in case of Docker, also we will be having our virtualization software. We will be having our virtualization. Virtualization software. See, whatever the virtualization software it is, it can be Hyper-V, it can be hypervisor, it can be Oracle VirtualBox, it can be VMware. Okay, whatever it is, virtualization software will be there on top of this operating system. Now, here, this is the virtualization software. On top of this virtualization software, we are going to have multiple virtual servers. We are going to have multiple virtual servers, VMs, in the previous diagram which I mentioned. Okay, let me take only one VM for your understanding. Okay, so let me take one VM and we will be having multiple VMs. Let me take ... something like this. Something like this. We are going to have multiple VMs on this physical server because of this virtualization. Okay, this VM, now let me take this VM. This is a VM, virtual machine. This VM has 3 GB of RAM and 3 CPU, 3 GB of RAM and 3 CPU memory. Oh, sorry, 3 GB of RAM and 3 CPU. Okay, we have 3 GB of RAM or memory or 3 CPU, which is there. These are the resources that are available with this virtual machine. On top of this virtual machine, we will be having something called guest operating system. Guest operating system, we call it as. Okay, so we will be having guest. Okay, let me take this one. Something like this. Guest operating system. We are going to have guest operating system. On top of this guest operating system, we are going to install Docker. We are going to install Docker. This is how also in real time works actually. Okay. where they are going to install Docker in real time. Most of the people, they are going to install Docker on this virtual machines. They are not going to install directly on the physical machine or the physical server. They are going to install the Docker on these virtual machines where they deploy their applications. Okay, where they deploy their microservices. Okay, what happened to this? 1 second. Now, this is going to be our what is this? Docker engine. Okay, we are going to deploy our Docker engine. We call it as Docker software or Docker engine. Okay, whatever it is, we are going to deploy our Docker. What this Docker helps us, we can deploy multiple applications as part of this virtual machine, something like this. App 1, you can deploy app 2, something like this. Okay, you can deploy app 3. Okay, something like this, app 3. Okay, so something like this, multiple applications can be deployed onto this virtual machine where we have installed Docker. These applications are nothing but containers, we call it as. But yeah, we are going to enter that terminology, but yeah, do not worry about that as of now. Okay, we can deploy multiple applications, something like this. This is going to be app 1 and this is going to be our app 2. Okay, app 2, and this is going to be our app 3. Actually, this is going to be our app 3. Okay, here out of these 3 GB of RAM and 3 CPUs that are available with this virtual machine, application 1 is using 1 GB of RAM and 1 CPU. Let me write it for 1 GB of RAM and 1 CPU. And application 2 is using 1 GB of RAM and 1 CPU. And application 3 is using 1 GB of RAM and 1 CPU. There will be a better resource usage here. There will not be any resource wastage. You can see that entire 3 GB of RAM and 3 CPUs is properly utilized in case of Docker. You can see that here entire 3 GB of RAM and 3 CPUs were properly used. There is no resource wastage in case of Docker. Okay, you can see that very clearly as part of this. Okay, now
sorry to interrupt, Shiva, but in physical server virtualization, in that can't we install 2 apps in one VM?
no. You need to install, you are deploying the applications, right? So you need to install only one application in one VM. Suppose if you install 2 different applications in one VM, if that application is going to be, if that server is going to be down, or if some problem is been appeared with that server, okay, 2 different applications. So see, there might be problem with the server or there might be problem with the application number 1. Okay, so 2 different applications will be going to be down in case of that one. Generally, people want to deploy multiple applications in a single server because they should maintain high availability. One application fault should not affect other application. That's what their intention is, and they will be installing. It's not best case to install 2 different applications in a single machine. You need to install 2 different applications in 2 different machine actually. So something like that.
So my question was, in the previous image you have shown, in one virtual machine, we have one application. Am I correct?
Yeah.
So here you are saying that in one virtual we have more than one.
Yes.
So is there any limitation with the virtualization software in physical server in that case where Docker is not there?
Yes, there are limitations actually. Okay, you cannot. Okay, let me go to the diagram 1 second. Yeah, this one, right? So we have resource wastage in this case actually. That's what the limitation is. As of now, just think only that limitation. There are much limitations than this. Okay, So as of now, in the case of virtualization, we have resource wastage because we are not going to deploy multiple applications into a single virtual machine. That's we are not going to do actually, because that's not a best case. We will be deploying multiple applications in a multiple servers. So as part of this virtualization, we have a limitation called what is this, resource wastage. Because of this resource wastage limitation, we will be moving towards a Docker. Not only this, just it's an example which I have given. Not only this resource wastage limitations, there are many limitations that are available, but yeah, it's not a time to discuss those. Because of those reasons, we are moving towards a Docker. Suppose if we deploy, one more limitation is, if we deploy our application to our virtual machine, something like this, you cannot properly monitor this application, how our application is working. Suppose I want to monitor how many number of requests coming to this application. I want to create nice visualization graph. Suppose this many requests are coming, out of this many are successful, and out of this many are failure. This many, suppose 100 requests are coming, 50 are successful, 50 are failure. That cannot be possible with this if you deploy the application directly on the physical server. Okay, there are a lot of disadvantages or the limitations like that we have if we deploy our applications directly on the physical server. Okay, so one of the example is just I have given as an example as resource wastage, but yeah, there are many like that. Okay, so because of those reasons, we are moving towards a Docker actually for better performance, but for better resource usage, for better monitoring, better visibility of our application. So all the things we will be getting with the Docker actually, something like that.
Okay.
Anyone have any questions, please? This is where we are stepping into the Docker. Okay, first people used to deploy their applications on the physical servers only, and they found many disadvantages there, like that we have mentioned, and they moved towards the virtualization. And in the virtualization also we have disadvantages like whatever we have seen, resource wastage. Okay, so because of those reasons, because of the disadvantages that we have, if we deploy our application on the virtualization virtual machines, people move towards a Docker. Docker will be giving us many advantages, and Docker with the combination of Kubernetes will be used in the where in the industry level actually. First you need to know the Docker, how the containers are created, how the applications are converted into containers. All these things you need to know, then only you will be understanding Kubernetes. So something like that. Okay, so first step in order to enter to Kubernetes, this container runtime engine like Docker. Okay, so something like this. Okay, so now this is going to be entry point for our Docker. We are going to enter into the Docker. And one more thing, because of this recent resource wastage also Docker has been occurred. And one more thing is also there, because of the entry of microservices to this world, Docker has been popular. Okay, because of the entry of microservices that are being entered into this world, Docker has been popular. What are microservices? What are microservices? Before going to that question, anyone have any questions with the concept that we have discussed? Anyone have any questions?
Hello.
Yeah, tell me.
Hello. Hi, sir. Satish here. So I'm totally new in this Docker and Kubernetes and this virtualization. So while you were giving this example, so just wanted to know for the just if I want to practice in my local machine or my laptop. So suppose in our office or in industry, what they do, they install the database in different server, application in different server. So in this case, if I want to practice, so if I have one laptop only, in that, what I should do, whether I should create two virtual machine where I will install one database server in one VM and application in another VM, or I can use this approach, like in one VM, I will install the Docker and I will use database as well as application in different images.
You know it of as of now, as of as of now, until I say, you don't need of installing anything, everything, this virtual machines, because if you these are the huge softwares, Docker and the virtual machines or Oracle VirtualBox. If you want to install, you need to create a virtual machine, right? So in order to create a virtual machine, you need to deploy, you need to install Oracle VirtualBox. These are huge softwares. I will not suggest to install this in your local machine, because everything we are going to do it in cloud. Okay.
No,
So
that is okay. Just for my knowledge, means just to create a replica, like how they
yeah,
create. So
for your,
what, how? So I just wanted to know your suggestion. What will be the best?
yeah, if you want to install in your local machine, you need to install the Oracle VirtualBox. You no need of deploying the operating, you no need of deploying the database in one virtual machine, and you no need of deploying your applications in different virtual machine. You can deploy two things in a single virtual machine. We are going to do that. You can deploy two things in a single virtual machine. You can establish a connection between your application and the what is it, your database in that virtual machine itself. Okay, that's possible.
Okay. Thank you.
Yeah.
Hey, hi Shiva. I just
Right.
had one question. I mean, how do we manage high availability using Docker engine?
See, we manage high availability using Kubernetes for our applications that are deployed with the Docker actually. In case of Docker, because of the disadvantage, there are disadvantages in the Docker also. Okay, if this
Okay.
container has been deleted, there is no new container will be coming up immediately because of those reasons. There is no high availability.
Sorry to break you.
Yeah.
See, you're mentioning the word container. I mean,
Yeah.
where does that come into the picture? See, we have a Docker engine and we have a number of applications here.
See,
And
this
what is
each
the container?
this
Okay.
each application in Docker, we call it as container. Okay, this app
Okay,
1 is a
fine.
container, app 2 is a container, and app 3 is a container.
Okay.
Okay, so if this, in case of Docker, if this container got deleted, okay, somehow, there is
Okay.
no high availability with the Docker actually. Okay,
Okay.
because of that reason, because of some this is one of the reason. Okay, because of this reason only we are moving towards a Kubernetes. Kubernetes is an orchestration technology. Even our application is being deleted, not entire physical server or not entire virtual machine. If the problem
Okay.
appears with our application also, Kubernetes is responsible to recreate the application. You don't know of manually recreating that. Kubernetes as an orchestration technology, it will take care of that. As of now, with the Docker, there is no high availability in case of applications actually.
Okay, and just one more question with the curiosity. Consider, I mean, are we using the Docker engine anywhere in our IT, or we have already moved to Kubernetes?
No. Docker is used. See,
okay.
Kubernetes without Docker, Kubernetes without any container runtime engine like Docker cannot be there actually. If Kubernetes, if anyone are using Kubernetes in their IT, internally they are using container runtime engine. It might be the Docker,
Okay.
it might be the containerd, it might be the different container runtime engines they are using internally, because they are not using, like, they are not using explicitly, like, they are, if they are using Kubernetes, they are using Docker. That's it. Internally, Docker software is installed on the machines using Kubernetes. Yes.
Okay, and one more question. What if the Docker engine goes down? I mean, all the 3 applications will be down, right?
Yes, all the 3 applications will be down.
Okay.
And your Kubernetes, there itself the Kubernetes importance comes. Your
Okay.
Kubernetes
I mean,
will take care of that.
to resolve all this issue, Kubernetes came into the picture, right?
Yeah.
Okay. Thank you.
Yeah. Okay. So there are some, I'm not saying Docker itself is a final thing. There are some disadvantages with the Docker, as you mentioned, some of the examples. High availability in case of our applications, this is not there with the Docker. Okay, there are some disadvantages with the Docker also. So we will be seeing that after the Docker completion, why we are moving towards a Kubernetes. Okay, so this is how, as of now, we are stepping into the Docker. So this is one of the reason, that is resource usage, better resource usage, better monitoring of our applications in case of Docker. So the other why the Docker has been more popular, because of the evolution of microservices. what are microservices. What are microservices? Most of you people might know, because yeah, you people might be coming from the developer backgrounds, right? So just for your reference, for people who don't know, okay, just I'm explaining this. Okay, so suppose this is going to be our Amazon.in application. So something like this. Just let's think this is a Amazon.in application, is the e-commerce application that we have actually regularly. We are going to enter into that, right? So Amazon.in application. In this application, there will be multiple components. Okay, there will be a payment related functionality, that is one component. There will be a separate component for the electronic goods functionality. So for the electronics, so only separate component. There will be separate component for your clothing, something like that. Okay, different components. Okay, so something like that. Let me write what are the different functionalities or components that Amazon given to us actually. So suppose we have payments component as part of this Amazon.in application. We have payments component. This is our payments component. And the second component that we are going to have, that is mentioned actually, just we are taking few examples, that are there are many components, something like this, right? So electronics. Okay, so this is electronics, right? Suppose something like this, electronics. We have a component called cart, right? We are going to add some goods to the cart, something like that. That's a cart component. Okay, this is electronic. Okay, so this is something called, there is something called going to be cart. I hope you people know what is cart, right? So cart is something like where we are going to add our selected items to that cart for the checkout purpose, right? So something like cart. And we have something called clothing, right? Clothing. Right? So this is one more component, one more functionality that is provided to us by the Amazon.in, right? So something like this. Okay, suppose let's think this is Amazon.in is a monolithic application. What is monolithic application first? Okay, let's think this is a monolithic application. Monolithic application. Okay, what is this monolithic application? What is this monolithic application? What is the monolithic application is, all the functionalities will be created as a single application. Entire Amazon.in application will be created as a single application. Okay, all the functionality like payments, electronics, card, clothing, or whatever we have mentioned here, all whatever the functionalities that are provided by the Amazon.in. Okay, all the things will be created, developed by the developers as a single application, only one application. Okay, so let me write that point here. That's a monolithic application. So all the entire application is developed as a single application. The entire application is developed as a single application. There are many disadvantages with this. Many disadvantages with this. Let's discuss few of them, or one or two of them. Okay, suppose one example is, there is a new bank that has been come into the market. The bank name is XYZ. Okay, so a new bank has come into the market. The bank name is XYZ. This is a new bank. What the Amazon people thought, Amazon people want to allow this new bank payments from their portal, also from their application. This need to be allowed actually. Okay, something like this. Okay, says no, not this one. How to select this one? 1 second. Yeah, this one, right? So Yeah, suppose this new bank that is being come into the market, they want to allow the payments from this new bank also. They want to add this functionality to this Amazon.in application. So what is the disadvantage here? Because see, entire application is developed as a single application here. If there are any changes as part of any of the component in this application, we need to, or the developers need to do the changes for the other components also. Suppose if they want to add a new functionality to the payments by allowing XYZ bank payments, if they do any changes like that, code changes, that means program changes, application program changes, that will also affect other components. Suppose that is affecting the cart, that is affecting the cart. Okay, if we add a new bank, in the case of monolithic, as they are created as a single application, there will be dependencies between the applications. There will be dependencies between the components, not the application. There will be dependencies between the components, something like this. If any changes happens with the payments, that is affecting the cart, okay, cart functionality. If there is, see, as we are changing the, suppose I have added new bank and I have changed the cart functionality also, cart code also. As I have changed the cart code, I also need to change the clothing code, because these are dependent on each other. Okay, as I have changed the cart code, I need to change the clothing code as well, something like this, because they are dependent on each other. Okay, so here, like that, they are dependent on each other. There will be dependencies between the components in case of monolithic. Yeah, okay. Because of this, yeah, okay, I have added a new bank. Suppose I have added a new bank and I have made changes to the code wherever the dependencies are there. Entire changes are I did as a developer. I did as this created as a monolithic application. I did, no problem. I've spent some time. I have did the changes to our applications. Okay, all the application. Even though I have added this one functionality to these payments, I did the changes to this all other functionalities, because there are some dependencies between the components that are there with this Amazon.in application, that because that is monolithic application, right? I have did, no problem. Suppose I want to make available, suppose I have completed code development, right? I need to deploy this to production now. I cannot directly deploy. You need to perform testing. All the things are done. Okay, so this new version of the application, Amazon.in application, need to be deployed to the production. Suppose this is going to be deployed to the production. This is going to be deployed to the production, something like this. Their production means production servers will be there. Okay, production server is there. Suppose this is a production server on which our Amazon.in application is running. Okay, this is going to be the server. Okay, so for changing only payments functionality, all other functionalities of electronic cart and clothing got changed. Because of this changing of all other functionalities, you need to restart or the reinstall, redeploy entire application on this server. Okay, entire application. Okay, because I have changed only the payments, but it asked me to change all other components in this, as part of this Amazon, because they are dependent on each other. Because of this, I need to restart all the components, entire Amazon.in application. I need to restart on this server. Actually, entire Amazon.in application I need to restart. Suppose in order to restart entire Amazon.in application and recheck everything is working fine. Suppose let's think it is taking 20 minutes. It is taking 20 minutes of time to restart. Okay, so just think how much business impact the Amazon.in application people, the Amazon people will be having if the application is going to be down 20 minutes. Even though we deploy this Amazon.in application to the server, even though after 20 minutes, it cannot be, we are not 100% sure that it will be working good. Okay, 20 minutes down means how much business impact that Amazon.in is people going to have actually. Okay, there is huge business impact. Okay, So because of this reason, okay, so this is one of the reason, okay, there are many reasons like this. Because of this reason, microservices has come into the picture. What are microservices? Here, in the case of monolithic, all the application component will be developed as a single application. Okay, payments, electronics, card, clothing, and whatever the functionalities that is provided by the Amazon will be developed as a single application. But in case of microservices, individuals applications will be developed. Suppose for payments, a different application. Suppose this is a payments application, a different applications. These are, suppose this is a payment application, PAYMENTS, payments, and we have another application for card. We have card application, something like this, card. Okay, card, CARD, card. And we have our electronics, something like this. This is going to be our electronics application, separate applications. Okay, electronics. Okay, we have our clothing application, separate applications. Okay, so this is going to be our clothing. Okay, clothing application. You can see that here all the components are developed as a single application, but in case of microservices, each component will be developed as a separate application, and there will be communication between these components. There will be a communication between the cart and payments, electronics and the payments and the clothing, electronics and the cart, because after selecting the electronic goods, you are going to able to add that to the cart, right? So how you are able to add? Because of there will be a communication between the electronic component and the card component. Okay, something like this. Okay, so there will be a communication between these applications, individual applications. So clothing also we have a communication. Okay, something like this. Okay, we are going to have with this cart, because the clothing also we can able to add to the cart, and a cart should be able to communicate with the payments application in order to do a payment. Okay, something like this. Okay, these individual applications are nothing but microservices. Okay, these individual applications are nothing but microservices. Instead of developing all the components in a single application, developers are going to develop separate applications for each component of that particular application. Okay, so each like particular enterprise application. Okay, so each component is something called microservice. Okay, here payments application is something called microservice, cart is microservice. Okay, electronics application is microservice, and clothing is microservice. So, and here in case of Docker, and these are deployed as a Docker containers. Okay, these are deployed as a Docker with the help of Docker engine. Each application is going to be deployed separately using Docker. Okay, each application payments will be deployed as a Docker container. Okay, so cart is going to be container means something like this. In this left side in this diagram, you can see that, right? So that's a application 1, application 2, application 3, which I have mentioned. These are payments, electronic goods, clothing, and application 4, something like that. Okay, so each application will be deployed as a separately. Okay, instead of all them, because they are developed as individual applications, right? So each application is going to be deployed separately, something like this. Okay, on the servers, something like this. Okay, they are going to be deployed separately. Okay, so okay, now in this case, in the case of microservices, I want to add a XYZ bank to these payments. I want to add XYZ bank to these payments, which I've taken in the previous example. I want to add a new functionality that is called XYZ bank to these payments. There will not be any dependency between these applications because they are individual applications that are developed by the developers. There will not be any any dependency between this application, between the payments and the cart, between the payments and the electronics, between the payments and the clothing, between the clothing and the cart, and electronics and the cart, there will not be any dependency. If you add this XYZ bank to this payment functionality, a new bank that has been come into the market, you no need of restarting entire Amazon.in application on the server, because they are not dependent on each other. In the case of microservices, you only will restart payments application on the servers actually, okay, which is being developed with the new version with new bank. You know it of restarting all other different applications which we have as part of Amazon.in. In case of microservices, you will be only restarting the payments application. Now, in case of payments restart, you will be observing this. In the case of Kubernetes, it is going to take less than 5 seconds to restart payments application in the Kubernetes clusters. Okay, so it will going to take less than 5 seconds. Okay, less than 5 seconds. Okay, you will be observing this. Okay, it is going to take very minimum amount of time. You can see that for adding one simple bank to this payments functionality, in case of monolithic application, it's taking 20 minutes. For example, I have taken, but yeah, it is going to take 20 minutes because they are dependent on each other, and then entire application should be restarted. Okay, but in case of microservices world, it is going to take less than 5 seconds, from 20 minutes to 5 seconds. Just think the difference. Okay, so that's what the advantage you are going to get as part of the Docker and Kubernetes. One of the advantage. Okay, so that's a thing. Okay, so yeah, this is where because of this reason, the Docker and Kubernetes were more popular in the industry actually. Okay, so people who are the developers and the DevOps engineers, or the whoever the cloud engineers, or whoever the people are there, so everyone should know these three tools, that is Docker, Kubernetes, and the Jenkins actually, because yeah, Jenkins is for automation. Okay, so you need to definitely know these three tools, because yeah, that's a very popular nowadays. Okay, so this is where the things come in. And if you have any questions, you can ask now. Okay, tomorrow we are going to start the Docker architecture and remaining parts of the Docker terminology. Before explaining the Docker architecture, you need to understand what is Docker container, what is Docker image, what is Docker host, what is Docker client, what is Docker repository, or the Docker registry, private Docker registry, private Docker, public Docker registry. So all these things you need to understand. Okay, so tomorrow we are going to we will be going through that terminology, and then we will be moving towards the Docker architecture. Okay, if you have any questions, you can ask any questions, please. Is that clear, everyone? Is that clear? Are you people getting what I'm speaking?
Yes, Shiva. I mean,
Yeah.
just I wanted to confirm this. This payment application, cart, and electronics, clothing, all this will be running as a separate microservices, right?
Yes.
Okay. And how are they interconnected?
They are connected with something called DNS names actually. When you deploy
Okay.
these applications into the somewhere on the server or the Kubernetes cluster, these applications are going to get some name, DNS name we call it as. Okay, so with the help of, suppose if the cart application want to connect to this payments application, so it will use the payments DNS name, cart will use the payments DNS name, and it will connect to that application actually. So something called
Okay.
DNS is there. Yeah.
Yeah, you just mentioned we'll be deploying this to the Kubernetes containers, right? So if
Yes.
we are deploying all these applications on Kubernetes containers, this payment will be in the different container and cart will be in the different container, or all these microservices will be in the same container.
No. They are going to deploy it as a separate containers actually.
Okay.
Okay. So if they are in the same containers, again, same problem, right? Again, going to 30 minutes.
Got it.
Okay. So
Yeah.
yeah.
Okay, Shiva. Thank you.
Yeah. No. Microservices and the application. See, services not. Microservice and the application are same. Refer to same. Microservices means all these 4 microservices: payments, cart, electronics, clothing. Here, payments application is one microservice, cart application is one microservice, electronics is one microservice, and the clothing is one microservice. Okay, something like that. Okay, all combinedly known as microservices, and they run for single application like Amazon.in application, so something like that. Okay. Yes, those are part of application. Microservices part of application. Okay. Yeah. Okay. So that's it. So that's a class for today. Tomorrow we are moving towards the Docker. And please go ahead and register for the course. Our demo sessions are going to be completed soon. I will be mentioning on what date tomorrow. Yeah. Please go ahead and register if you like. And then we'll meet in the next class. That is on tomorrow, 9:30 a.m. morning, same time. Okay. Thank you. Thanks for joining. I'll meet you in the next class. Thank you.
Yeah, thank you, Shiva.
How many days will it take to complete Docker? It is going to take, I think, 12 or 14 sessions or something like that. Okay, so something like that. Yeah, thank you. Bye.